On the screen in front of you, you should see a laboratory implement called a burette. A burette is used to accurately dispense solution for use in an experiment. It's two main parts. You've got a plastic tubular portion here with graduated markings along the side, and I'll go over how to read those in just a moment. And you've got what's called a stopcock, which is essentially a valve. So the tubular portion is a couple feet tall, and if you look up here at the top, it's filled to the zero graduated marking here with sodium hydroxide. So this whole tubular portion is filled with sodium hydroxide, and should I choose to dispense that, I would do so by using the stopcock. This switch here, if I turn this so that you can see it, it's closed right now. The switch is in the horizontal position. If I wanted to dispense, if I wanted to place some kind of flask underneath of it to dispense solution into, I would just turn the switch to the vertical position, and that would begin to allow solution to flow from the burette into whatever was underneath there. As far as the markings go, the most important thing to note about a burette is that unlike most other implements that you use that have the graduated markings like this, a burette reads down. So you'll notice as here at the bottom, so to speak, you actually, most of the time with like a graduated cylinder or something like that, you would start at 0, and your numbers would increase as you go up the side of the implement. Here it's different. Here you're actually starting at the maximum number at the bottom, and it decreases as you move up. So at the top, if you see, start here at 50 and move up, all the way up at the top here is 0. Okay, and then it just increases down the tube to the bottom where you have 50. So that's called reading down, or set of burette reads down, and it's really important to be aware of that when you're taking measurements with one of these things. And the reason that it does that is because these markings aren't actually measuring how much solution you have in the burette. These markings are actually measuring how much you've dispensed into whatever you have underneath. So if I had a flask sitting underneath of the burette, and I opened the stopcock, okay, and I filled it with 10 milliliters of solution, if I filled that flask with 10 milliliters of solution, you would lose 10 milliliters here. That's why this reads down. The level would drop, right? It starts at 0. If I dispensed 10 milliliters, the level in this thing would drop to about right here, where it says 10. If I dispensed 20 milliliters, it would drop to about here, so on and so forth. Just important to understand, this reads down because you're measuring how much you've placed in some kind of container underneath, how much you've dispensed. These do not measure how much you have in the burette. And the other thing to notice is that the ones and then the first decimal place, the tenths place, is marked. So it reads 1 decimal. You can infer a second. And so for the purposes of these labs, you should report your burette readings with 2 decimal places, not 1. This experiment asks you to perform 3 sets of measurements using a burette. The first set of measurements are used to help standardize a sodium hydroxide solution. The second set of measurements pertain to determining the molarity of a sulfuric acid solution, and it will use the standardized values that you get from the previous part for the sodium hydroxide to do that. The last set of measurements you'll need to make help you to determine the molar mass of sodium oxalate dihydrate. I have the burette set up now to go ahead and start the standardization of sodium hydroxide, which is labeled on your data sheets as Part 2. I have my burette, which I showed a moment ago. This here is the stopcock again. And I will rotate this in a moment so that you can see as I perform the titration how to open and close the valve to dispense solution and control the rate of flow. Underneath of it, I have an Erlenmeyer flask that has been filled with a small amount of solid, white crystalline solid. It's called potassium hydrogen phthalate. Again, it's a white crystalline solid, and the lab manual gives a range of masses that you can use. So for each of your trials, the same amount that you use may or may not be the same, but there is a range of values that are acceptable, and we try to stay within that range. Additionally, this has about 25 milliliters of distilled water, which is why you don't see any white solid. It's all gone into solution after we added the water. And there are 3 drops of phenolphthalein, which is an indicator. The phenolphthalein is what is going to help us to determine when we are finished with the burette. When we've reached the end, what's called the end point of the titration, the solution should be a light rose color. Now, sometimes you'll get a color change and it will not remain. It appears and then it disappears shortly thereafter. And so during the course of these titrations that I'm going to do, and I'm going to demonstrate one of each part, it may be that we stop, we hit our endpoint, and then it turns out that the color change disappears after a moment, and so I'll need to add a little bit more thereafter. That is common and is no cause for concern. This is sitting on a stir plate. This whole the flask is sitting on a stir plate. And what's going to happen in a moment is I'm going to drop what's called a stir bar into the solution. This is a stir bar, just a Teflon coated piece of metal with magnetic properties. We're going to use the stir plate to manipulate this magnetically. And what it will do is stir the solution for us. When you carry out titrations like what we're going to do today, you need to be able to keep both of your eyes on the solution at all times, and you can't concentrate like that as you need to do if you're having to stir. So the stir plate's going to help us by alleviating that problem. So with that, the burette, again, as I showed earlier, is filled all the way up with the sodium hydroxide. According to the label on the bottle of sodium hydroxide, this is 0.1 molar. However, that's not, just because the label says that, does not mean that that is actually the case. And so what we're going to do is we're going to check to see if indeed the sodium hydroxide has a concentration of 0.1 or not. Usually the value comes out to be a little less than 0.1, and that's what I'm expecting here. Now, if you were to do this lab in person, you would do this, what I'm about to do, this process 3 times. And then you would average your concentrations. You'll be given a set of volumetric measurements. You'll be asked to determine your concentrations and then average them on your data table. And that average that you calculate for the sodium hydroxide in part 2 is what you will use as the concentration of sodium hydroxide from there on. So even though the label says 0.1, if you calculate it to be 0.097 or 0.098, that is what you will use for the rest of this lab. So with that, I'm going to go ahead and get started. Again, everything's set up. First thing I'm going to do is take my flask, and I'm going to place my stir bar in it. So I'm just going to do it like this. So that's present now. And I'm going to activate the stir plate by using the right dial. You can already see that the stir bar is beginning to rotate. And I'm going to put it at about 700 and let that go. When I go to remove the stir bar, I will use this magic wand to actually pull it out of the beaker without having to invert the beaker, or the flask, excuse me, or do anything else to it. So with that, I'm going to begin the titration. Let me turn the burette so that you can see the stopcock and see how I manipulate it. So again, this is what I'm going to use to dispense the sodium hydroxide into the flask here. And it's closed because the switch is in the horizontal position. I'm going to flip this slowly towards the vertical position and allow the sodium hydroxide to begin dripping drop by drop into the flask. Now, if I were going to do 3 trials of this on camera, you would notice the first trial I would go very, very slowly, and then the second and third I would use a greater flow rate basically from the outset. The first trial is important because you have no idea where you're going to stop. But once you've completed the first trial, you should have some idea how many milliliters of sodium hydroxide it's going to take to reach your endpoint. And so if I did my first trial and it required about 12 milliliters, then for the second and third trial I would go ahead and dispense 6 or 7 pretty quickly and then cut the flow rate back after that, because again, this should be the same concentration. Everything should be roughly the same concentration here, so there shouldn't be a lot of variance in how many milliliters of sodium hydroxide I need to use to reach my endpoint. So you won't see me do the second and third trials, but for the first trial, again, the drip rate will be pretty slow, and then I would for the second and third trials, I would allow it to go quite a bit faster, at least in the beginning. So with that, I'm going to open the stopcock here, again, moving towards the vertical position, and you should start to see droplets right there. Now we're just going to keep an eye on this and carefully watch for anything resembling a color change. Again, we may get a slight color change that dissipates after a moment, and so I may have to stop and restart the titration a couple times to get a color change that actually stays. The other thing to note is that, again, you should only see a light coloring of the solution. If you were to do this and you got a color change, it was like a bright flamingo or a pink or a fuchsia, then that means you've overshot your endpoint. The color change that you want should be light and barely visible to the eye. If it's easy to see from a distance, then you have overshot the endpoint. You have used too much sodium hydroxide or too much titrant, whatever you're working with, and that will greatly obscure your measurements. Okay, I'm beginning to see a slight color change every time the drop hits the surface of the solution. It doesn't stay, but I know I'm getting closer to my endpoint because it's becoming more pronounced. So I've got my hand on the stopcock to cut the flow off as soon as I need to ensure I don't overshoot my endpoint. And there you have it. So this is the color change that you would be looking for. It's actually a little bit darker than what I would like, but I wanted you to be able to see the color change, so I kind of allowed it to overshoot by just maybe a drop. It's a close-up of it. Ideally, it would be just a little bit lighter than this, but again, I was afraid you might not be able to see the color change. So the last step here is to go ahead, take the distilled water. You'll notice that there are droplets all over the walls of the flask. So that's sample loss that we want to keep in our measurements. And so what I'm going to do is I'm going to just set this on the table here. Okay. and I'm going to take my distilled water bottle and I'm going to angle it. And what I'll do is begin squirting water into the flask. And as I do that, I'm going to rotate the flask. So the water will wash down the sides of the flask and make sure that all of the KHP that we started with remains in solution and not spattered on the walls of the flask. So, just like that. Just make a couple rounds real quick. Like that. And you should be good. Now you'll notice that it's actually lightened. You can't really see it on the camera. I can still see a very, very light pink hue or rose hue. That'll happen as it sets. Gradually it will lose its color change over time. So for part 2, if you were in the lab, you would do 2 more trials just like this. And then again, you would get your concentration of sodium hydroxide for each trial and average them. And whatever that average is, that is what you would use for the rest of the lab anytime it called for sodium hydroxide. Okay, I've angled the camera in the hopes that you could take a gander here at the burette. This is how you would read it. I mean, you would look. Now, I'm a little bit above where you would be. Let me see if I can see if it'll resolve itself. But you can see the meniscus is clearly between 14 and 15, and it really looks like it's about 14 point maybe 7.3 or 7.4. The main thing to note is that, again, 14, 15. So it's below 14 because you're reading the burette down like I discussed a moment ago. It's going to be 14 something or other, right? That's the important thing to note here.